Hello, boys. So you have seen the task 2, task 3 with graphs in the last class. I think you understood the essentialities and importance of the graph. Now I'm going to the third task in your syllabus. There is that. But before that, let me have a look at some of the graphs. That are used to represent some of the best results. So I think you'll follow it closely and try representing most of the things that we see in life as in the graph. So here is the graph of the sun compared with other planets. This is our sun solar system, and then you can see that they have been scaled to size. Suppose if this is 100, okay, and this will be scaled down to the size of about say for example the size is too large, then you can make it 1000. If you make it 1000, you can just compare it how many balls you can fit here. So you can draw just the size of the balls there, and just draw a few in a one fourth or a quarter of that, and find out there are about 50 such balls can sit there. So that means this is 1 by 1000 size of that. That is the Venus, 1 by 1000 of the size. Look at Earth, our own Earth. So here it is, and it is the size is already there. Okay, it is about just slightly larger than the Venus. And then they have used this amount of energy for the Death Star to destroy the planet in the in nuclear chemistry. I think you have read about this nuclear chemistry. Every planet is a dead star. Okay, this is actually a dead star. A star has got burning fuel, and when every fuel is exhausted, it cools down, and it is called as the nuclear junk. So by that way, Earth is a nuclear junk. Junk now waste. Nuclear junk is a waste thing, so it's a waste product. So Earth is a waste product here, but because of the minerals that are there and because of the requirements of the human beings, it has become very richer, and man's greediness is responsible for everything that is there on the Earth we are facing now. So the size has been scaled, and you can see the Jupiter is the largest. Even about 20 Jupiters can fit into the sun. That is there. But here they are calculating the amount of energy for the Death Star to destroy planet in the system. So they have used up this formula U equal to gm square p by rp, where G is gravitation constant. We don't go much details into that, but what is important is they have calculated the energy as equal to 2 into 10 power 36 joules, 1.2 into 10 power 34 joules. This idea is there. So they have scaled it according to the size and the energy required for destroying uh, this planet. Okay, so this is a kind of graph. Not only this, you can take up the several things that you consume in terms of the energy. See, for example, you can take up the uh, food that you take in a dish, okay, and calculate its energy. See, for example, rice. So okay, rice, every time you take the large amount of rice, then some amount of this rice, it is having some amount of energy there. You can calculate it in joules. And then the next thing you take up is the sambar. Calculate that in joule, and according to that size, suppose if it is 100, sambar 100 kilocalories, sambar is having 50 kilocalories. Draw a circle which is about 50 times that of the rice one. Okay, so put rice as the major one, and then draw some other things. Like for example, you have got the side dishes in the form of kire, urka, kute, all those things. Okay, okay, just you can put it in the linear manner when drawing a graph there, and you try just start writing explaining this. So a graph doesn't require any literal things. The best thing is, you can draw a graph to represent your results. Okay, the next figure I like this very much is how fast you can get there. So he's taken some examples there, and this is our star sun. Okay, So he has taken the example of Proxima Centauri, the next star in our neighboring star in our planet. This is our neighboring neighbor star. Okay, I think you have heard the news today. We received some signals, radio signals from this to the Earth. Okay, radio signals have been received from this, and it is very strange thing, and they are analyzing it. And we have been trying to find out if there are any aliens. Aliens means, I think, foreigners, so those who do not belong to Earth, if they are present or not, we're trying to find. So this signal that came last week from this Proxima Centauri star in this direction is having some strange signal. So the distance is about 4.24 light years from the sun to the Proxima Centauri. And if you start from the Earth is somewhere here, and if you start from that, if Usain Bolt starts running at about 44.7 kilometers per hour, it will take 102, 444, 823 years, so much amount of years. So it is only light year is different from general year. Light velocity of light is 3 into 10 power 8 meters per second, and how much time it takes up for traveling in 1 year is calculated at light year. Okay, so it goes like this. Then if a cheetah is traveling at a speed of 120 kilometers, and then it is going. So the scale is, I see, is getting on lengthened there. The faster you have a vehicle, the longer is the distance graph there. So you have got this aeroplane got Astratus CC, which travels at about 1,228 kilometers per hour. It will take so much years, 37,229, 37 lakhs 29,058 years. Concorde, I think this Concorde is nowadays the French aircraft which was flying at the speed of twice, thrice the speed of light. We call it as speed of sound. We call it as a 3 Mach. It is now grounded because of some problem, because it has three Concords made some accidents, and so it has been grounded. So it can take up at about 21 lakh, 21 crores, 21,000, 21 lakh, 1,553 years. Then you have this New Horizon. New Horizon, it was launched in about 10 years back. So it crossed Pluto, and it is still going for some other discovery. So if you want to read this about this, there is a very good book called as the New Horizons. New Horizon. It's a very good book by Alan Stan. He was the man in charge of it, and he has written a very good book. You can find review of this in my website. Go to my website. My website is www.imranpkm.blogspot.com. I have written a review of this after blogspot.com. There is a review of this book in my website. You can see how beautiful it is written, how fast it travels. It is having a radioactive source as energy, plutonium. So that powers the aircraft. It is traveling there. So now this one is something which is this particular spacecraft is a fictional one. Fictional one. It's found in a movie called as Star Wars. So it is supposed to travel at the in less than 12 hours. It can reach from this. So it doesn't exist. So it has random moments. So you can see that it is taking up some curved path. So this is taking up the advantage of the space-time curve. Space-time curve. So now you can see here you have used distance to scale them to graph them. Okay. And the next graph is that now the cubic building side of about 107 kilometers. So this is going to be about 107, 107, 1.07 km. That could hold all 7.3 billions on the planet. The world's tallest building, and the building added for reference is there. So here is the world's tallest building is there. This one, and here you have this Burj Khalifa there. Burj Khalifa is there. Okay. So if you build up a square cube like that, you can accommodate all the 7.3 billion human beings inside. The world's entire population. So what he's trying to say is, we are spread. several places we are living. So if we all are gathered here, this particular cube is about 1.07 kilometer in length, 1.07 kilometer in breadth, and 1.07 kilometer in height. Can accommodate all the 7.3 billion humans. Now it is about close to 7.5 billion. 1 billion is equal to 100 crore. So 700 crores, people live there in the earth. Okay, 700 plus crore people live on earth. People live on earth. Okay. So what he has done is, he's calculated each person is requiring that, and then he has integrated all this by using this mathematical formula and put a graph of this particular cube, which can accommodate all the human beings. So that is just to represent how much things are. This is another beautiful graph of about, we must know how our atmosphere is there. So if you here you can just see that is giving unit is given in miles. 1 mile is equal to 1.6 kilometer. Okay, so you just have this. You see, you can see this. This is the mountains, and the aircraft is flying there. That that particular layer where aircraft flies is called as the stratosphere. Here is where you have got the clouds, and these are the clouds that bring rain. Troposphere is just the layer of the atmosphere, and where you have got all the atmospheric air and see. Then mesosphere is a very hot layer of the air. So if you got about 50 miles, means it is about 80 kilometers. So if you go above the earth, there is a very hot layer there, and then because of this hot layer, there is a layer called as the thermosphere, and it is about 100. And as you go up, we can see the things that are then. This is green line air glow that they call it as aurora. You can see there. Red line glow, it is also a part of the UV glow, it is also there. And as you go up, you can see International Space Station, which is still there. It has been there since 1990, and a lot of scientists are visiting this by using the rocket there. Then another satellite is there. So it is trying to explain by using the different layers of the Earth. There are 5 major layers of the atmosphere that I am not going to discuss here, but here that can be used to represent here. This is another graph, which I says the angular size. Angular means, it is circular. It has got some angle. So 180 degrees is the angle that they have taken. Angular size, the sun as seen from each planet, aphelion and perihelion. Aphelion means, suppose if you have a circle like this, if you have sun, right, this will be called as the distance between this center and this one is the smallest distance. So this is a very large distance, right? That is called as the perihelion. Okay, called as the perihelion. So this distance between this and this will be very short. The shortest distance will be called as the aphelion. So it is trying to calculate the different size of the earth compared with the sun, like this. So you can again compare this, and here is another beautiful one. This picture represents the night in the, in fact it should be night sun in the polar regions. Polar regions means North Pole. The earth is so much tilted that the sun has to go on setting like this, so it is crossing like this. In our earth, what happens in our area, like in India, the sun goes down, it goes down and goes down, and then it goes down, it goes down, and then you get dark here completely. But what happens is the earth is so tilted that sun does not set here, it again rises back here like this. So there is no sunset. So you have got 6 months of day and 6 months complete night in regions. 6 months night completely in regions like Antarctica, and even in a country like Norway, where there is a only slightly light is, darkness is there in summer, and full darkness in the winter there. So they have visited this place, taken the photograph. Perhaps how many photographs he has taken. So this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 photographs is taken, and merged all these 9 photographs to explain the curvature of the earth like this, and the sunset on the polar region. So this graph is also able to explain how you can present a particular large amount of data there. Now this is about the, again, this is very useful thing. You just have to find out what it is. So this is the, yeah, it's called as the meteors. I think meteor. The stones that come from the earth, that come towards the earth. Okay, they burn up in the atmosphere, and you always see them some light in the sky. Okay, so he has just taken up the general meteor. So this is that meteor there. Okay, so it starts from January. In January, you got meteors called as the quaternion meteors. In February, you don't have anything. In March, you don't have anything. In April, you have Lyrid meteor. And between March and April and May, you got Eta Aquarids, and then uh, you can just see that Lyrid meteor is there in June, Aquarid again in July, Capricorn. No, so these are the name Perseid metal. These are very dense. You can see it naked eye if your sky is clear. There is nothing in September, and in October you have Draconites and Orionites. Orion, I think we know about the Orion. It's the constellation of the group, it's constellation of the stars, which is nothing but the group of stars. Then we have Taurus, the Leonids, Gemini shower. This we saw this month in December. Okay, and then Ursid meteor between December. Now it is going on there. So in the month of December, these are the meteors that are there. Okay, Leonid meteor in November. So this is the every cycle of the meteors, cycle of meteors, you can represent it by just some graphs. So they have also taken the color of this to explain, which is very dense. These are very light, and this is very dark. Means they are changing, and has given it in terms of the winter and summer, or even in terms of the intensity of that. Okay, so here is the another graph of juxtapose. Okay, they have juxtapose means what is meant by juxtapose? Taking several pictures. So how many pictures he has taken? Just to count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 pictures he has taken. Okay, 20 pictures he has taken, and just this you can see the different sky there. Here it is plain, and here it is cloudy, and here also it is cloudy there. So in this figure, it is trying to explain the sunset with the winter solstice. Winter solstice means, I have seen this just now. We have seen it. 21st December is the winter solstice, in which you have the longest night. Summer solstice means longest day. Okay, so he has taken it about 6:13 p.m. All the pictures have been taken at the 6:13 p.m. But you can see the difference in the sunset, how it goes. So that is a kind of observation he is trying to make to tell you about the more details are not needed now. I'm just telling how a group can picture to explain this. Okay, this one is again a map based graph. These are several graphs. Not only this is kind of a 3D graph that is there. You can see in this graph, a solar eclipse, path of solar eclipse is there. So it crosses over the North America, starts from the uh, Pacific Ocean here. Okay, and then you have to find out the matter to write. That is what is there: Pacific Ocean, Atlantic Ocean. So it starts from Atlantic Ocean, and it starts in Central America. So you must be able to know all these places there. Okay, so this particular line, how you have to write matter. This particular line is 100% eclipse, and just if you move away from this plus or this plus, you will be getting 90% of the eclipse. As you move away further, you get 75% of the eclipse. As you move away, you getting 25% of the eclipse. 25% of the eclipse. So this is also 25% of the eclipse there as you move away, and that way it is. As you go here, you have don't no eclipse at all. No eclipse at all. So that is the way to represent some graphs. Some events you just scale, and you have to find the suitable software way to present it. So if they ask you to write essay about that, you can just start writing that this is about the path of the solar eclipse, and it starts from the North American continent, and you must know this place, which is California, and how it crosses through Utah and southern regions and goes to the eastern part, and which part are receiving 75%, which is receiving 50% of the eclipse. and the graphs, this the regions that have been classified, they have you have to write that also. You have to write the okay, the period also there. So here is this one is taken from your book, so that is why I have taken. Now it is talking about the air flow that is there from the in the month of, I think, look out if there is any month is present or not. So it is talking about the June 1st. So it is a monsoon that really starts in this particular direction. It starts visits Kerala first, and then it moves in the westwardly direction like this, and then it crosses. So some other bit from the Indian Ocean is coming here, and it is pushing up into the Bangladesh, and then as a result of this, this is going towards the Himalayas, and this is a kind of monsoon that brings line up to the New Delhi. See how this kind is impacting the monsoon is going in this direction, in this northwesterly direction, and then towards the west completely. So here are some of the wind that are also capable of a western monsoon, and then there is this thing called as the period. June 1st is given, June 10th is given, June 15th is given, and the July 1st is given there. So here you have to answer, why does the monsoon usually start in Pakistan? Monsoon is, it goes in July 15. So you have to write about July 15 there. Hyderabad can expect rains to start from. Where is Hyderabad? Here it is. This is Hyderabad. So you just have to, when it starts from. Actually, in June 10th, there was a lot of rain there. I think you know. The cities, this is the southernmost point I seen in the map is, Trivandrum. It is given only this one. Okay. It's Trivandrum. There is the answer there. What is the following place in the chronicle that is the answer to the monsoon? Chronology is date wise. So you have started from June 1st and June 10, and then June 15, and then July, like that it goes, July 10 or something like that. So which are the cities that goes there? So they go like this, it goes like this. So you have to name the cities and then name the river that flows between Madras and Hyderabad. So there are so many rivers along this. It is given there: Krishna River, Godavari River, and what more? There is no. The only two rivers are given there. If you know more, you can just write them. The monsoon that brings rains to Kalvi, which is the following direction. This is the north direction. This is brings which of the following. The monsoon that brings rains to Calcutta moves in which of the following direction? In the direction of the monsoon is going this direction. So this is east, right? Actually, it should be northeasterly to be exact. No, northeasterly. So you can write northern or because it is completely moving towards north. You can write north, and if you just say that it is going towards west, northeast. Okay, both are there. So you have to say that it is northeasterly directions. Okay, so you take out any graph and start writing in the context of the graph and explain the things that are involved. You must be able to write at least one page for that. If you are doing that, then well and good, and you have learned the art of writing, doing things there. Okay, so in this session, they have this. I think we have finished this about the graphs and the writing more about the writing things about the graph. I think we have finished this. We'll go to the next thing in our next session. Thank you for joining me. See you soon.